All right, so guys, today section 1.1, rectangular coordinates. Rectangular coordinates. As I mentioned a minute ago, I feel very much like, again, if we want to take on the approach that let's not think about this as, oh, I'm teaching you these things, I'm reminding you these things. Again, you're going to hear me talk about it that way a lot. I am a firm believer in mindset, and again, how you set up your brain to receive information, that makes a big difference. And if you're going into something thinking, oh gosh, I've got to learn this, I don't know anything about it, that's a different way of thinking as opposed to, okay, I've seen most of this before, we're going to go a little bit further. I'm gonna hit some reminders along the way. And again, not to give away all the secrets here on day one in the first minute of the first lesson, but that's pretty much what pre-calc is. We're going to remind you of a lot of things. It's just that we're putting multiple concepts together to create success, and that's really where we're at. So rectangular coordinates, section 1.1. The goals or the objectives that we have, we want to be able to plot points in their Cartesian plane, fancy word for the XY coordinate plane. Use distance formula to find the distance between points. Use midpoint formula to find the midpoint of the line segment. And then we want to be able to use the coordinate plane to model and solve some real life problems. So, yeah, that was awesome. Okay, so on to the next page, if it'll let me go. There we go, distance formula. All right, so obviously you've seen the distance formula before. Not just once either. This is probably the fourth class now in a row that you've seen the distance formula, maybe fifth if we have anybody who was in Algebra 3 last year and is coming over from there after a year with Mr. Nicole or Mr. Moore. Again, you've seen this in Algebra 1, you saw it in Geometry, you saw it in Algebra 2, and we're absolutely going to see it and use it here. Honestly, it's not like an every problem you better be ready to go with the distance formula. That's not it at all. It's just that occasionally it's going to pop up and we have to know how to handle the distance formula. One of the things that's really important to me is that we've made the connection that the distance formula, it's just the Pythagorean theorem. That's really all that it is. Has everybody seen that connection before? Like, hopefully your geometry teachers spent some time, but I'm seeing a lot of people shake their heads no, that didn't happen. All right, so the good news is it's really not super complicated. We think about way back in the day. I don't know when that is, but if we wanted to find the distance between these 2 points, we wanted to figure out how long that was. What we actually had to do was figure out, well, vertically, what's the difference? Horizontally, what's the difference? And now we just created a right triangle. So in order to pull this off, once we know the vertical and the horizontal distances, we're going to use the Pythagorean theorem. Well, if we're on a coordinate plane, we think exactly, all right, well, this point is x1, y1. This point is x2, y2. Again, we're trying to just be very, very generic. Obviously, if we're really in a coordinate plane, we could come up with real, actual coordinates in those cases. But if I wanted to calculate what exactly is that horizontal distance, all that we would do is we would take our x2 value and subtract our x1 value. Okay? If I wanted to figure out this vertical distance, all that we would do is take this, well, we're going to do it this way, the y2 value and subtract the y1 value. Obviously, that's going to give us a negative answer, but we're going to square it and then square root it anyway to get rid of that. Does that make sense? Are these values starting to look familiar as far as the distance formula? That's all that it is. So it sounds funny when I say that the distance formula is a shortcut to the Pythagorean theorem because in my mind, I'm sure just like all of yours, the Pythagorean theorem seems easier, seems more effective or efficient. But imagine if we're trying to find the distance between these 2 points. Look at all this extra drawing that I had. That all took time. Right? So we had to create a right triangle before we could use the Pythagorean theorem. If we already have the coordinates, we could just go directly there with the distance formula. So it is a shortcut. Now, whether you ever think of it this way again, that's going to be up to you. I would be willing to bet or assume that a lot of us just feel really confident with the distance formula the way that it is. You've used it hundreds, if not thousands of times in the last few years. Okay? Questions on distance formula? Square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so if we were to practice this, we were to give it a shot. We do have choices here, but let's call this first one x1, y1, second point x2, y2. I say that we have choices because this was interchangeable, wasn't it? We've called that first point x2, y2, second point x1, y1. Sure, no reason why we wouldn't be able to do that. So the distance is going to be the square root of, now we just start plugging in. So we've got to go x2 minus x1. So we look up there, x2 is 3 minus x1 is negative 5. We're going to have to square that. Plus y2 minus y1. Well, what's the y2 value, please? Anybody? Negative 4. Minus the y1 value is 7. We're going to square that. Now we actually do the math. And with your help, 3 minus negative 5, it's a whole lot like 3 plus 5. What's that going to be? 3 plus 5 is 8. Square it, we get 64. We're over here doing the same thing. We have negative 4 minus 7. What's negative 4 minus 7? Negative 11. But then when we square it, we get 121. So we have the square root of 64 plus 121, which is going to give us the square root of 185. Now, we want the exact answer. We just found it. Square root of 185. It doesn't break down. It doesn't simplify. That's our exact answer. Now, I will say that the vast majority of the time in pre-calculus, we are searching for exactly that. We want the exact answer, the most precise answer. But that's because we have no context to this problem, meaning it's not a word problem. We're not saying that root 185 actually, we don't know what that means or represents. Now, if this were a word problem, and I should have thought this out, we're calculating how much trim you have to buy for finishing your floor in the basement, and you go to Home Depot and you say, all right, I've got all my calculations. Guy at Home Depot, could you help me out? And I need the square root of 185 feet of this trim. They're going to look at you like you're crazy if that's the case. That would be a situation to where going with a decimal approximation would be much more appropriate. Does that make sense? All right, so again, the difference between a word problem and a non-word problem, again, if it doesn't specifically say, we always assume that we want the most exact answer. Okay? All right, midpoint formula. How many of us feel like we have the midpoint formula memorized? Okay, good, good. And if you feel really confident and comfortable with the midpoint formula, then don't let anything I'm about to tell you, talk you out of it or sway you in a different direction. But I think it goes back to all the years that I was teaching the geometry courses. And then also now I still do a lot with the ACT prep stuff. But I would encourage you not to try to sit here and memorize the midpoint formula as x2 or x1 plus x2 over 2, comma y1 plus y2 over 2. That's true. It works. It's exactly it. But mathematically, if you add two things and then divide by 2, what are you finding? The average. So for whatever reason, it just clicks better in a lot of people's minds if you just think midpoint formula, just average the x's and the y's. That's it. That's all that you're doing. Adding the x's together, dividing by 2. Adding the y's together, dividing by 2. Mathematically, we're not doing anything differently than if we memorize this or if we just say average x's and y's, but it's a little bit simpler as far as how we're going to get there. And if nothing else throughout the course of this year, I'm hopeful that I can give you a whole bunch of those little, all right, yeah, this is an easier way to think. Hopefully we can get you a lot of those. So we're going to go ahead and calculate if my x's between these two coordinates are negative 5 and 9. We have to add them and divide by 2. So we have negative 5 plus 9. We're going to divide by 2. Same story with the y's. We have negative 3 and positive 3. We're going to add them and divide by 2. So if you help me out here, what is negative 5 plus 9 as I sloppily wrote that? Positive 4, divide that by 2, we get? All right. Negative 3 plus 3 is? 0 divided by 2 is? So the midpoint will be located at 2 commas. All right, guys, how do we feel about distance and midpoint formulas? Pretty good? Congratulations, we just finished the first section. Only 655 to go. Just kidding. It only feels that way. Section 1.2, let's take a look at 1.2. We're going to talk a little bit more about graphs of equations. Graphs of equations. So the goals or objectives that we have, we want to be able to sketch graphs of equations. Now, this is something that throughout Chapter 1, like this is going to be a big part of Chapter 1. I know that a lot of students would probably say that graphing is not their favorite thing. But where we're going to be possibly by the end of this week, like I said, fingers crossed. But if we get to section 1.6 on Friday, as we have it penciled in right now, we're going to start talking about parent functions. And you may hopefully remember a lot about parent functions, but we're going to kind of take that to the next level. And how we use parent functions, that's what we talk about in section 1.7. In fact, next week, I've got to look, I believe it's Tuesday of next week, we have our first quiz scheduled. And the quiz is just over parent functions. Like basically, if you know your parent functions and how to transform them, you're fine. And it is a short quiz. It's not anything too crazy. And we'll obviously talk a lot more about that, but I would just want to give you a heads up. But that is our first goal. We want to start talking about sketching the graphs and equations. I want to be able to find x and y intercepts. We want to use symmetry to sketch the graphs. And we want to find equations of and sketch graphs of circles. Basically, circles not being polygons, they occasionally have a different set of rules, but we don't want to forget about those. And then finally, we want to use graphs of equations in solving real-life problems. You might come to notice that that's generally going to be one of our goals, to say we want to link this back to the real world. Again, real-life problems, how can we pull that off? We always put that up there. We may not do a bunch of examples out of the real world, but eventually that's, like I said, where we want to go with this stuff. All right, so the graph of an equation. Okay, I apologize in advance. I generally don't like to just read stuff off of a slide, but sometimes I type it up the exact way I want you to hear it and see it. So let's go ahead and take a look at this one. It says that, for instance, the coordinate 1, 4 is a solution. Okay, is a solution of y equals 7 minus 3x. And the reason why it's said to be a solution is that when we let x equal 1, then y equals 4. So, once again, not telling you anything that you haven't seen and heard a lot of times, but maybe you haven't seen it and heard it exactly this way. Why is it that 1, 4 is a coordinate, is a point that's on that line? That's the reason why, is that if x is equal to 1, y is equal to 4. That's why we have a coordinate at 1, 4. Just like, and I don't know the next one off the top of my head, but if we were to plug a 2 in place, if I put a 2 in place for x, it looks like y is going to be 1. So at 2, 1, we're going to have another coordinate. We're going to have another point there. If I put a 0 in place for x, it looks like y is going to be 7. So we could do this all day. You have done this, like I said, hundreds, thousands of times in the past, but that's what we refer to as a solution. That's what makes this statement true. Now, once again, just so we're all on the same page here, what does that mean to be a true statement? Let's not overthink this and make it more complicated than it needs to be. If you have an equation or a function of any type, what makes it true is if the left side is equal to the right side. That's it. It's really easy to do some work and say, well, the left side is 6 and the right side is 7. Well, those aren't equal to each other, so that's not a true statement. We could write it up. It's just not true. Okay? Like, I mean, I could write this, no problem. Yeah, this is awesome, but that's not true. Okay? It's not a true statement. In order to be a true statement, the left side and the right side have to be equal to each other. Like I said, pretty obvious stuff, but it's just more the verbiage, the terminology. We want to make sure that we're all on the same page. Okay? So in this section, excuse me, we're going to review some of the basic procedures for sketching the graph of the equations of two variables. The graph of an equation is going to be the set of all points that are solutions of the equation. So again, the equation itself, it's not identifying one point, it's identifying the infinite number of points that fall on that line. Once again, you've heard this, you've seen this. One of the things you're going to hear me, you'll probably grow tired of hearing me say this, honestly, but I feel very firmly that one of my main roles as a math teacher is that of a translator, okay, in some way, shape, or form. You might read through this, or again, more often than not, because I think it's also important that you see the textbook form of definitions of theorems, of things like that. I want you to see that. I want you to have access to the formal way that it's written. But it's then my job to help you to understand what that actually means, okay? You've probably already seen it and noticed it, but in math, as you progress, which you guys are definitely progressing pretty quickly in your math courses, all that's really happening is that if you're looking at the textbook, it's just getting more and more complicated year to year to year, and that's going to continue. I wish I could tell you, yeah, once you get to calculus, then it's like at a second grade reading level. No, it's not. That's obviously not true. But again, how can we read through what information they're giving us, say, okay, that's what it says. Here's what it really means. Here's what we're actually supposed to do. Okay, so that's, like I said, a big portion of my role here. All right, I'm going to stop the video here. I would like for you guys to go ahead and try this next example, just verifying that when you put a 2 in for x, we get a 13 out for y, and then let's try the same thing for b. So go ahead and give that one a shot. while I stop this video and upload, please.